Today we will continue one important concept in theory of equation. This is basically related to the reciprocal equation. So first we will know about the reciprocal equation and the different theorems and properties of reciprocal equation. After that we will solve related problems. And special we will choose that problem which are important in different competitive examination as well as the graduation course. So now first we'll know what is the definition of the reciprocal equation. So our first recall about the definition. Definition of reciprocal equation. Reciprocal equation. So what is the definition? A polynomial equation. A polynomial equation is said to be a reciprocal equation. Is said to be a reciprocal equation. Reciprocal equation if the reciprocal of each roots, if the reciprocal of each roots, each of reciprocal of each of its roots is also a root of it, is also a root of it. So what exactly mean by this? What is the meaning? The meaning is if let fx equals to a0 plus a1x plus an x to the power n, where an is non-zero and all a0, a1, an are real number, be a reciprocal equation. Be a reciprocal equation of degree n, having roots alpha 1, alpha 2, alpha n. You know, the equation of degree n, it has n roots, no more. So the roots are basically, we assume here, alpha 1, alpha 2, alpha n. Then we can say, here 1 by alpha 1, 1 by alpha 2, dot 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 1 by alpha n is also a root. Also roots of fx, as it is a reciprocal equation. So what I said, polynomial equation is said to be reciprocal equation if the reciprocal of each of its root is also a root. So that is basically our first observation. As for example, if we think about the example, so our example is say x square plus 1 equals to 0. So you know what are the roots of the equation? The equation of degree 2. Degree of this equation is 2. So roots are basically plus I and minus I. And you will do the reciprocal of its roots. That will be 1 by I and 1 by minus I. And that is, it will be minus I and I. Again, it is a root. They are the roots of fx. So that means x square plus 1, according to the definition, is a reciprocal equation. reciprocal equation. Similarly, you will take the example x square minus 1 equals to 0. The roots are 1 and minus 1. You take the reciprocal of the roots 1 by 1, 1 by minus 1. That means 1 minus 1 again. That is also a root. So this equation is also a reciprocal equation. So reciprocal equation is one particular kind of polynomial equation where if we take the reciprocal of each roots, that will be again a roots of the equation. So now we'll come to one important problem under reciprocal equation. For the next observation, this is observation 1 under reciprocal equation. Now we'll come to the observation 2. Observation 2, and this observation is very important. So just to think, if 0 as a root, so 1 by 0, that means infinity. This is not possible, so 0 is not a root of the reciprocal equation. Okay, so here a necessary condition for fx equals to 0 for the polynomial equation fx equals to 0 to be a reciprocal equation, reciprocal equation is that 0 is not a root. 0 is not a root of it. That means what I am saying, f0 is basically not 0. So this is the necessary condition of fx to be a reciprocal equation. As for example, if you have asked, you have given a polynomial fx equals to x square plus x, and you have asked this polynomial equation fx equals to 0, reciprocal equation, our answer is no, it is not a reciprocal equation. Why it is not a reciprocal equation? And since f of 0 equals to 0, that implies that is not satisfied the necessary condition of fx to be a reciprocal equation. So that implies fx equals to x square plus x equals to 0 is not a reciprocal equation. So this observation is very important. Now we come to the next important remark. The remark is what is the remark? This is remark 1. Let a0 x to the power n plus a1 x to the power n minus 1 plus an minus nx plus an equals to 0 be a reciprocal equation. Then it is identical. Then this equation is identical with the equation a x to the power n plus an minus 1 x to the power n minus 1 plus a1x plus a0 equals to 0. And since it is identical, therefore we can write the coefficient of the first polynomial, that means a0, a1, an minus 1 an. This will be some k, the coefficient of this an minus 1, a1, a0. Now from this we can write a0 equals to kn, a1 equals to kan minus 1, an minus 1 equals to ka1, and an equals to ka0. And hence it implies k equals to plus minus 1. Why k equals to plus minus 1? Just you observe here a0 equals to kan and an equals to ka0. So from that we can write a0 equals to kan. In position of an you just put this value. So ka0, that implies a0 equals to k square a0. And that implies k square equals to 1. And that implies k equals to plus minus 1. This is a simple observation. This two equation will be identical, and from that you can write k equals to plus minus 1. Now we'll come to the important theorem of the reciprocal equation. What is the theorem? So here, theorem 1. This theorem is important. Let fx equals to 0 be a reciprocal equation. A reciprocal equation of degree n, and of the first type, then we can say fx equals to x to the power n f of 1 by x. But before that, we need to explain what is exactly meant by the first type and what is exactly meant by the second type. Then we will continue the theorem. So recall reciprocal equation. First we will write the reciprocal equation. So this is say a0 plus a1x or a0 x to the power n okay, a0 x to the power n plus a1 x to the power n minus 1 plus an minus 1x plus an equals to 0. Just you consider this is a reciprocal equation, and you know this equation is identical with this n x to the power n, an minus 1 x to the power n minus 1, a1x plus a0 equals to 0. So if one is a reciprocal equation, then 1 and 2 are identical, and from that case, here we will write a0, a1, an minus 1 an. This is equals to, because they are identical, so k into an minus 1, a1, a0. And from this we can get k equals to plus minus 1. That we discussed here in the remark 1. So what is the value of k? K is plus minus 1. Now we come to the 2 case. So case 1, if k equals to 1, and case 2, if k equals to minus 1. So if k equals to 1, in that case a0 equals to an, a1 equals to an minus 1, and an equals to a0. And if k equals to -1, so a0 equals to minus n, a1 equals to minus n minus 1, an equals to minus a0. So in that case, the reciprocal equation is called reciprocal equation. Under case 1, it is called reciprocal equation of first type. If k equals to -1, this is called reciprocal equation of second type. So if we think about an example, just for example, we have given 2x square plus 3x plus 2 equals to 0. So this is a reciprocal equation of first type. Why? Because you will see a0 and a3, an are equal. Or you can say, you can take the example, the 2023 x cube plus 2x square plus 2x plus 2023 equals to 0. Here you will see these two, the first and last coefficient equal, then these two coefficients are equal. So that means you will observe if a0 x to the power n, a1 x to the power n minus 1 plus dot 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 a n minus 1x plus a n equals to 0. That will be the first type. The first and last coefficient will be equal. The second first and second last are equal. In that we will continue. Okay. So here are the reciprocal equation of second kind. The example is say 2x square plus 3x minus 2 equals to 0. Here you will see they are equal with respect to the magnitude, but they are opposite sign, 2 and minus 2. So here a0, a minus 1 opposite sign. Or you can take the example 2023 x square, say minus 2x x cube minus 2x square plus 2x minus 2023 equals to 0. So here you will see the first and last are equal magnitude, but they are opposite sign. Also the second and the third is equal magnitude. So from that observation you can conclude the reciprocal equation of which type, first type or second type. So what is written in the theorem? If fx equals to 0 is a reciprocal equation of degree n and of the first type, then the relation holds fx equals to x to the power n f of 1 by x. That result is very, very important. Okay. And so I am writing the recall our theorem again. Let fx equals to 0 be a reciprocal equation of degree n and of the first type. Now you understood the meaning of the first type. Then what is fx? Fx equals to x to the power n f of 1 by x. Conversely, the converse part is also true. Conversely, if fx be a polynomial, of degree n and f of x equals to x to the power n f of 1 by x, then we conclude fx equals to 0 is a reciprocal equation of degree n and first type. So now we come to the proof. So how to prove? First we consider fx is a reciprocal equation of degree n from and for first type, then we prove fx equals to x to the power n. So we consider let fx equals to 0 fx equals to say degree n, that means we can consider is a0 x to the power n plus an x to the power n minus 1 plus an minus 1x plus an be a reciprocal equation of degree n and of the first type. What we have to prove? Here we have to prove that f of x equals to x to the power n f of 1 by x. That we have to prove. So now what we will write? Since fx equals to 0 is a reciprocal equation of first type. So what is the relation between coefficient? So a0 will be a1 an, a1 will be n minus 1. So a0 equals to an, here k value is 1, a1 equals to an minus 1, and so on. And an equals to a0. This is Roman 1. Now we'll continue from fx. Now what is our fx? Our fx is a0 x to the power n, a1 x to the power n minus 1 plus dot 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 n minus 1x plus n. If we take common x to the power n, so what will happen? It will be a0 plus a1x plus an minus 1 x to the power n minus 1 plus an by x to the power n. Now what will be f of 1 by x? So from here f of 1 by x equals to a0 by x to the power n, a1 by x to the power n minus 1 plus an minus 1 by x plus n. So now from this, what we can write? X to the power n, in position of a0 we can write an minus 1 by x plus a1 by x to the power n minus 1 plus a0 by x to the power n. Why? By 1. What is 1? You will see an equals to a0 and a0 equals to n. We will put this value here, so x to the power n. What is this? This is basically f of 1 by x. Okay. So what we have proved? We have proved here fx equals to x to the power n f of 1 by x. So our first part is done. Now we'll come to the converse part. So what will be the converse part? The converse part is to consider let fx equals to a0 x to the power n plus a1 x to the power n minus 1 plus an x to the power n an minus 1x plus n. This is be a polynomial equation of degree n, and we consider fx equals to x to the power n f of 1 by x. What we have to prove? We have to prove that fx is a reciprocal equation of degree n. That we have to prove. Reciprocal equation of degree n. So now start from now what is given, fx equals to x to the power n f of 1 by x, that we will write. So what is fx? Fx a0 x to the power n, a1 x to the power n minus 1, a n minus 1 x plus a. This is x to the power n, f of 1 by x, so a0 by x to the power n, a1 by x to the power n minus 1 plus a n minus 1 by x plus a n. Now what we will write from that? What we will write? a0 x to the power n plus a1 x to the power n minus 1 plus a n minus 1 x plus a n. That will be a0 plus a1 x plus a n minus 1 x to the power n minus 1 plus a n x to the power n. Now we are just comparing the coefficients. a0 equals to a n, a1 equals to a n minus 1, a n minus 1 equals to a1 and a n equals to a0. This is the condition for a reciprocal equation of first type. So therefore fx equals to 0 is a reciprocal equation of degree n. So this completes the proof, and not only degree n, and here you have to show and of first type. First type, the degree n and of first type. Similar theorem, in the same way, if the theorem is if fx equals to 0 be a reciprocal equation of degree n and of second type then fx equals to minus x to the power n f of 1 by x. If it is second type, only minus sign coming here, and conversely if fx equals to 0 is a polynomial of degree n and f of x equals to minus x to the power n f of 1 by x, then what we conclude? Then fx equals to 0 is a reciprocal equation of second type. Now we'll think about another definition in the reciprocal equation. The definition is basically standard form. Reciprocal equation of standard form. Reciprocal equation of standard form. When a reciprocal equation is called a standard form, so that definition we need to memorize first, and then we will continue the problem. A reciprocal equation is said to be of standard form. Standard form. When it is called standard form, if it is of first degree, if it is of first degree, first type, so that means the coefficient a0 equals to an, a1 equals to n minus 1, first type, the first condition, and the second one is of even degree. So the degree of the polynomial equation is even. So that means if you have given a reciprocal equation a0 x to the power n, a1 x to the power n minus 1 plus an minus 1x plus n, will call it a standard form reciprocal equation if a0 equals to an, a1 equals to n minus 1, n minus 1 equals to n, and n equals to a0. The first condition. Second condition, the degree of fx equals to 2n type, 2k type, where k is basically natural number. So that means degree is even. Okay. So now we'll come to the most important problem in this chapter. The problem is prove that. So this problem is very, very important. So what is the problem? The problem is prove that the equation x plus 1 whole to the power 4 equals to a multiple x to the power 4 plus 1 is a reciprocal equation. If a not equals to 1, and solve it when a equals to minus 2. So there is two part of the problem. The first part, we need to show the equation is a reciprocal equation if a not equals to 1. In the second part, if we consider a equals to minus 2, then you need to solve this kind of reciprocal equation. So now we come to the solution. So the first part of the solution is, what is your fx? Your fx is x plus 1 whole to the power 4 minus a x to the power 4 plus 1. This is our fx. Okay. Now, the case is when a equals to 1. What we will see? We will consider f0. So f0 will be 0 plus 1 whole to the power 4. Your a is 1. 0 to the power 4 plus 1. Okay. So this value will be 0. And you know, if 0 is the root of the reciprocal equation, then of an equation, then it is not a reciprocal equation. That I said earlier. This is our observation. So here you will see the observation. The necessary condition of f is equals to 0 to be reciprocal equation is that 0 is not a root. So that means f0 non-zero. So if f0 equals to 0, here the note. If f0 equals to 0, from that we conclude fx equals to 0 is not a reciprocal equation. So that we will do here in this problem. Since f of 0 equals to 0 when a equals to 1, that implies fx equals to 0 is not a reciprocal equation. If a equals to 1. Okay. Now we come to the case. This is case 1. Now we come to the case 2, when A not equals to 1. Okay, because it is given, you need to prove the reciprocal equation if A not equals to 1. Because we proved A equals to 1, it is not a reciprocal equation for A equals to 1. But when A not equals to 1, now we'll check what is happening here. So you will see the degree of fx, this is basically 4. Okay, and what is f of 1 by x? So f of 1 by x will be 1 by x plus 1 whole to the power 4 minus a 1 by x to the power 4 plus 1. So just you will do the calculation. 1 plus x whole to the power 4 minus a 1 plus x to the power 4 by x to the power 4. So this is basically fx by x to the power 4. So what we got? We got here fx equals to x to the power 4 f of 1 by x. Okay. So now we come to this theorem. What is theorem? If fx be a polynomial of degree n and fx equals to x to the power 4 f of 1 by x, then fx is a reciprocal equation of the first type. Okay. So what we conclude? Since fx is a polynomial of degree 4 and fx equals to x to the power 4 f of 1 by x, if a not equals to 1, then we conclude that fx equals to 0 is a reciprocal equation of first type, in fact of first type, okay, if a not equals to 1. So thus you will write the answer. The first part is done. The equation x plus 1 whole to the power 4 equals to a into x to the power 4 plus 1 is a reciprocal equation. If a not equals to 1. If a not equal, the first part is done. Now we'll move to the second part. If we consider a equals to minus 2, so minus 2 basically not 1. That is basically the reciprocal equation in that case. So in that case we will solve the problem. So when a equals to minus 2, the equation is that will be x plus 1 whole to the power 4 plus 2 into x to the power 4 plus 1 equals to 0. Okay, and obviously in that case this is a reciprocal equation as a equals to minus 2 not equals to 1, that we have proved earlier in the first part. So now we'll solve this problem. We can write the problem as x square plus 2x plus 1 whole square minus plus 2 into x to the power 4 plus 1 equals to 0. Now we just divide by x square. What we will get? We will get 1 plus 1 by x plus 1 by x plus 2 whole square plus 2 into x square plus 1 by x square equals to 0. So dividing by x square on the both sides. Now we'll take, say, let x plus 1 by x equals to t. So that means it will be x square plus 1 by x square. That will be t square minus 2. You just hold squaring both sides and you will find out x square plus 1 by x square, that will be t square minus t. Just we put here, that will be t plus 2 whole square plus 2 into t square minus 2, that will be 0. And from this we can write 3t square plus 4t equals to 0. So what is the value of t? T equals to 0, comma minus 4 by 3. Now we come to the case when t equals to 0. So that means x plus 1 by x equals to 0. And that implies x square plus 1 equals to 0. And that implies x equals to plus minus I. And when t equals to minus 4 by 3, that implies x plus 1 by x equals to minus 4 by 3. And that implies 3x square plus 4x plus 3 equals to 0. And that implies x equals to minus 4 plus minus b square minus 4ac. But just we apply just the Acharya formula. So here x equals to minus 2 plus minus root 5 iota by 3. So what are the roots? Therefore, the roots of the equation x plus 1 whole to the power 4 equals to a into x to the power 4 plus 1, when a equals to minus 2 are, what are the roots? I minus 2 plus root 5 I by 3 minus 2 minus root 5 iota by 3. So these are the roots. The equation of degree 4, it has a 4 roots. Now it will be exercise homework. You will solve x plus 1 whole to the power 4 equals to a into x to the power 4 plus 1 when a equals to 2. Okay, so when a equals to 2, that means it is not equals to 1. So it will be a reciprocal equation of first type. So you will solve it. Okay, this is your exercise. Now we'll come to the important question. The question is for MCQ type, for what values of a fx equals to x plus 1 whole to the power 4 minus a into x to the power 4 plus 1 equals to 0 is not a reciprocal equation. Not a reciprocal equation. So here option A is a equals to 0. Option B is a equals to 1. Option C is a equals to minus 1. And option D is a equals to minus 2. So what we have seen now, we have seen here, if we put a equals to 1, so your f0 will be 0, and that implies fx equals to 0 is not a reciprocal equation. So for A equals to 1, it is not a reciprocal equation. And we have proved here A not equals to 1, if x equals to 0 is a reciprocal equation. That we proved. So not equals to 1, that means if A equals to 0, minus 1 or minus 2, all are not equals to 1, and in that case it is a reciprocal equation. So this type of question is also important. That has been given in different examinations. As for example, you may be given in the B.Sc examination or SSC examination. Now we will do the another important problem. So what is the problem? So solve the equation. Solve the equation. This problem is also important. 6x to the power 4 plus 35x cube plus 62x square plus 35x plus 6 equals to 0. Now how to solve? First you observe it is of standard type or not and even degree or not. So obviously this equation is basically of degree is basically 4. It is an even number and it is of first type. So it is basically standard form. So first you will write the given equation is 6x to the power 4 plus 35x cube plus 62x square plus 35x plus 6 equals to 0. And you will see here the first coefficient and last coefficient are equal. So this is 6 and again you have 6. Second first and second last is also equal. And the degree is also even. So that means the reciprocal equation is of first type and even degree. Since the reciprocal equation one is of first type and even degree. So it is in the standard form. So if a reciprocal equation in the standard form, we can solve it very easily. And what will be the technique? The technique is this can be written as, so where the coefficient equal, that comes here. So you take the first term and the last term, first and last. So that will be 6x to the power 4 plus 1. We will take the second first and second last. So here the 35 will be common. The 35x, that will be x square plus 1. And so this is the easy trick. If it is in the standard form, so easily you can solve it. So now you will divide it by x square. The highest degree is 4. So you will divide by x, the half of the highest degree. That means x square. If it is x6, you will divide x cube. It is x10, we will divide x to the power 5. So dividing by x square, what we will get? We will get 6 x square plus 1 by x square. That will be 35 x plus 1 by x plus 62 equals to 0. So dividing by x square. So if it is even degree and of the first types, it will be very easy to solve. Okay. Now what you will take? You will take x plus 1 by x equals to t, and that implies x square plus 1 by x square will be t square minus 2. So what will write? 6 into t square minus 2 plus 35t plus 62 equals to 0. From that you will write 6t square plus 35t plus 50 equals to 0. Just you will do the factorization or middle term break. And from this you can write easily t equals to minus 10 by 3, or you can apply Sridhar formula, no problem, minus 5 by t. Now we have two cases. The first case is when t equals to minus 10 by 3. And another case we will introduce here when t equals to, so another root is minus 5 by 2. Minus 5 by 2. So in that case x plus 1 by x will be minus 10 by 3. So that means here 3x square plus 10x plus 3 equals to 0. And you will solve it, you will get x equals to minus 3 minus 1/3. And when t equals to, so that implies x plus 1 by x equals to minus 5 by 2. So that means 2x square minus 5x plus 2 equals to 0. And that implies x equals to minus 2 comma minus half. So what are the roots? Hence, the roots of the given equation are minus 2, minus 3, minus half, minus 1/3. You will observe, if we take the reciprocal of each roots, that means 1 by minus 2, 1 by minus 3, 1 by minus half, 1 by minus 1/3. That is also a root. So that's a simple observation. So thank you so much. And in similar way, we will do many problems from this chapter later. Okay. So this is the first concept, and we have solved here two important problems.